An LED lamp is a light-emitting diode product that is assembled into a lamp for use in lighting fixtures. LED lamps have a lifespan and electrical efficiency that is several times better than incandescent lamps, and significantly better than most fluorescent lamps, with some chips able to emit more than 100 lumens per watt. The LED lamp market is projected to grow more than 12-fold over the next decade, from $2 billion in the beginning of 2014 to $25 billion in 2023, which is a compound annual growth rate of 25%. Like incandescent lamps and unlike most fluorescent lamps, LED lights come to full brightness without need for a warm-up time. The life of fluorescent lighting is also reduced by frequent switching on and off. Initial cost of LED is usually higher. Degradation of LED dye and packaging materials reduces light output to some extent over time. With research into organic LEDs and polymer LEDs, cost per lumen and output per device have been improving rapidly according to what has been called Hertz's law, analogous to Moore's law for semiconductor devices. Some LED lamps are made to be a directly compatible drop-in replacement for incandescent or fluorescent lamps. An LED lamp packaging may show the lumen output, power consumption in watts, color temperature in kelvins or description and sometimes the equivalent wattage of an incandescent lamp of similar luminous output. LEDs do not emit light in all directions, and their directional characteristics affect the design of lamps. The light output of single LEDs is less than that of incandescent and compact fluorescent lamps. In most applications multiple LEDs are used to form a lamp, although high-power versions are becoming available. LED chips need controlled direct current electrical power. An appropriate power supply is needed. LEDs are adversely affected by high temperature, so LED lamps typically include heat dissipation elements such as heat sinks and cooling fins. Technology overview. General-purpose lighting needs white light. LEDs emit light in a very narrow band of wavelengths, emitting light of a color characteristic of the energy band gap of the semiconductor material used to make the LED. To emit white light from LEDs requires either mixing light from red, green, and blue LEDs, or using a phosphor to convert some of the light to other colors. One method uses multiple LED chips, each emitting a different wavelength, in close proximity to generate white light. This allows the intensity of each LED to be adjusted to change the overall color. The second method uses LEDs in conjunction with a phosphor. The CRI value can range from less than 70 to over 90, and color temperatures in the range of 2700 kelvins up to 7000 K are available. Application. A significant difference from other light sources is that the light is more directional, that is, emitted as a narrower beam. LED lamps are used for both general and special purpose lighting. Where colored light is needed, LEDs that inherently emit light of a single color require no energy-absorbing filters. White light LED lamps have longer life expectancy and higher efficiency than most other lighting. LED sources are compact, which gives flexibility in designing lighting fixtures and good control over the distribution of light with small reflectors or lenses. Because of the small size of LEDs, control of the spatial distribution of illumination is extremely flexible, and the light output and spatial distribution of an LED array can be controlled with no efficiency loss. LEDs using the color mixing principle can emit a wide range of colors by changing the proportions of light generated in each primary color. This allows full color mixing in lamps with LEDs of different colors. Unlike other lighting technologies, LED emission tends to be directional, which can be either advantageous or disadvantageous, depending on requirements. For applications where non-directional light is required, either a diffuser is used, or multiple individual LED emitters are used to emit in different directions. Household LED lamps, replacement for existing lighting, lamp sizes and bases. LED lamps are made that replace screw-in incandescent or compact fluorescent light bulbs, mostly replacing incandescent bulbs rated from 5 to 60 watts. Such lamps are made with standard light bulb connections and shapes, such as an Edison screw base, an EMA 16 shape with a B-pin base, or a GU 5.3 or GU 10 and are made compatible with the voltage supplied to the sockets. They include circuitry to rectify the AC power and convert the voltage to an appropriate value. As of 2010, some LED lamps replaced higher wattage bulbs. For example, one manufacturer claimed a 16-watt LED bulb was as bright as a 150W halogen lamp. A standard general-purpose incandescent bulb emits light at an efficiency of about 14 to 17 lumens per watt depending on its size and voltage. According to the European Union standard, an energy-efficient bulb that claims to be the equivalent of a 60W tungsten bulb must have a minimum light output of 806 lumens. Some models of LED bulbs are compatible with dimmers as used for incandescent lamps. LED lamps often have directional light characteristics. The lamps have declined in cost to between $10 to $50 each as of 2012. These bulbs are more power efficient than compact fluorescent bulbs and offer lifespans of 30,000 or more hours, reduced if operated at a higher temperature than specified. Incandescent bulbs have a typical life of 1,000 hours, and compact fluorescents about 8,000 hours. The bulbs maintain output light intensity well over their lifetimes. Energy Star specifications require the bulbs to typically drop less than 10% after 6,000 or more hours of operation, and in the worst case not more than 15%. LED lamps are available with a variety of color properties. The purchase price is higher than most other, but the higher efficiency may make total cost of ownership lower. Several companies offer LED lamps for general lighting purposes. The technology is improving rapidly and new energy-efficient consumer LED lamps are available. LED lamps are close to being adopted as the mainstream light source because of the falling prices and because 40 and 60-watt incandescent bulbs are being phased out. In the U.S., the Energy Independence and Security Act of 2007 effectively bans the manufacturing and importing of most current incandescent light bulbs. LED bulbs have decreased substantially in pricing and many varieties are sold with subsidized prices from local utilities. At some Walmart locations prices for LED bulbs have been under $1. LED tube lamps. LED tube lights are designed to physically fit in fixtures intended for fluorescent tubes. Some LED tube lamps are intended to be a drop-in replacement into existing fixtures. Others require rewiring of the fixtures to remove the ballast. An LED tube lamp generally uses many individual LEDs and may be directional. Fluorescent lamps emit light all the way around the lamp. Most LED tube lights available can be used in place of T8, T10, or T12 tube designations, in lengths of 2, 4, 6 and 8 feet. Lighting designed for LEDs, newer light fittings designed for LED lamps, or indeed with long-lived LEDs built in, have been coming into use as the need for compatibility with existing fittings diminishes. Such lighting does not require each bulb to contain circuitry to operate from mains voltage. Specialty uses. White LED lamps have achieved market dominance in applications where high efficiency is important at low power levels. Some of these applications include flashlights, solar-powered garden or walkway lights, and bicycle lights. Monochromatic LED lamps are now commercially used for traffic signal lamps, where the ability to emit bright monochromatic light is a desired feature, and in strings of holiday lights. Examples of commercial and industrial use. In 2008, Century Equipment Corporation in Oconomowoc, Wisconsin, USA, was able to light its new factory interior and exterior almost solely with LEDs. Initial cost was 3 times more than a traditional mix of incandescent and fluorescent lamps, but the extra cost was recovered within 2 years via electricity savings, and the lamps should not need replacing for 20 years. In 2009, the Manapakam, Chennai office of the Indian IT company, iGate, spent to the first $3,700,000 to light 57,000 sq of office space with LEDs. The firm expected the new lighting to pay for itself fully within 5 years. In 2009, the exceptionally large Christmas tree standing in front of the Turku Cathedral in Finland was hung with 710 LED bulbs, each using 2 watts. It has been calculated that these LED lamps paid for themselves in 3.5 years, even though the lights run for only 48 days per year. In 2009 a new highway was inaugurated in Aveiro, Portugal. It included the first European public LED-based lighting highway. By 2010 mass installations of LED lighting for commercial and public uses were becoming common. LED lamps have also been used for a number of demonstration projects for outdoor lighting and LED street lights. The United States Department of Energy has available several reports on the results of many pilot projects for municipal outdoor lighting. Many additional street light and municipal outdoor lighting projects have been announced. Comparison to other lighting technologies, see luminous efficacy for an efficiency chart comparing various technologies. Incandescent lamps generate light by passing electric current through a resistive filament, thereby heating the filament to a very high temperature so that it glows and emits visible light over a broad range of wavelengths. Incandescent sources yield a warm yellow or white color quality depending on the filament operating temperature. Incandescent lamps emit 98% of the energy input as heat. A 100 watts light bulb for 120 V operation emits about 1180 lumens, about 11.8 lumens per watt. For 230 V bulbs the figures are 1340 lumina and 13.4 lumina per watt. Incandescent lamps are relatively inexpensive to make. The typical lifespan of an AC incandescent lamp is 750 to 1000 hours. They work well with dimmers. Most older light fixtures are designed for the size and shape of these traditional bulbs. In the U.S., the regular sockets are E26 and E11, and E27 and E14 in some European countries. Fluorescent lamps work by passing electricity through mercury vapor, which in turn emits ultraviolet light. The ultraviolet light is then absorbed by a phosphor coating inside the lamp, causing it to glow, or fluoresce. Conventional linear fluorescent lamps have lifespans around 20,000 and 30,000 hours based on 3 hours per cycle according to Lamps NLPIP reviewed in 2006. Induction fluorescent relies on electromagnetism rather than the cathodes used to start conventional linear fluorescent. The newer rare earth triphosphor blend linear fluorescent lamps made by Osram, Philips, Crompton and others have a life expectancy greater than 40,000 hours, if coupled with a warm start electronic ballast. The life expectancy depends on the number of on-off cycles, and is lower if the light is cycled often. The ballast lamp combined system efficacy for then current linear fluorescent systems in 1998 as tested by NLPIP ranged from 80 to 90 lumina per watt. For comparison, general household LED bulbs available in 2011 emit 64 lumens per watt. Compact fluorescent lamp specified lifespan typically ranges from 6,000 hours to 15,000 hours. Electricity prices vary state to state and are customer dependent. Generally commercial and industrial electricity prices are lower than residential due to fewer transmission losses. In keeping with the long life claimed for LED lamps, long warranties are offered. One manufacturer warrants lamps for professional use, depending upon type, for periods of normal use ranging from 1 year or 2,000 hours to 5 years or 20,000 hours. A typical domestic lamp is stated to have an average life of 15,000 hours, and to support 50,000 switch cycles. Research and Development, U.S. Department of Energy. The Energy Independence and Security Act of 2007 authorized the Department of Energy to establish the Bright Tomorrow Lighting Prize competition, known as the L Prize, the first government-sponsored technology competition designed to challenge industry to develop replacement for the most commonly used and inefficient products, the 60W incandescent lamps and PAR38 halogen lamps. The EISA legislation establishes basic requirements and prize amounts for each of the 2 competition categories, and authorizes up to $20 million in cash prizes. The competition may also lead to opportunities for federal purchasing agreements, utility programs, and other incentives for winning products. In May 2008, DOE announced details of the competition and technical requirements for each category. Lighting products meeting the competition requirements would use just 17% of the energy used by most incandescent lamps in use today. A future L Prize program announcement will call for developing a new a 21st century lamp as authorized in the legislation. On September 24, 2009, the DOE announced that Philips Lighting North America was the first to submit lamps in the category to replace the standard 60WA19 Edison screw fixture light bulb, with a design based on their earlier ambient LED consumer product. On August 3, 2011, DOE awarded the prize in the 60W replacement category to Philips bulb after 18 months of extensive testing. National Institute of Standards and Technology. In June 2008, NIST announced the first two standards for solid-state lighting in the United States. These standards detail performance specifications for LED light sources and prescribe test methods for solid-state lighting products. The Illuminating Engineering Society of North America published a documentary standard LM79, which describes the methods for testing solid-state lighting products for their light output, efficacy and chromaticity. The solid-state lights being studied are intended for general illumination, but white lights used today vary greatly in chromaticity. ANSIC 78.377-2008 specifies the recommended color ranges for solid-state lighting products using cool to warm white LEDs with various correlated color temperatures. DOE launched the Energy Star program for solid-state lighting products in 2008. Environmental Protection Agency, in the United States and Canada, the Energy Star program since 2008 labels lamps that meet a set of standards for starting time, life expectancy, color, and consistency of performance. The intent of the program is to reduce consumer concerns due to variable quality of products, by providing transparency and standards for the labeling and usability of products available in the market. Energy Star light bulbs for consumers is a resource for finding and comparing Energy Star qualified lamps. Other venues. In the United Kingdom, a program is run by the Energy Saving Trust to identify lighting products that meet energy conservation and performance guidelines. Philips Lighting has ceased research on compact fluorescents, and is devoting the bulk of its research and development budget, 5% of the company's global lighting revenue, to solid-state lighting. In January 2009, it was reported that researchers at Cambridge University had developed an LED bulb that costs £2, is 12 times as energy efficient as a tungsten bulb, and lasts for 100,000 hours. Honeywell Electrical Devices and Systems recommend worldwide usage of LED lighting as it is energy efficient and can help save the climate. Energy Star qualification. Energy Star is an international standard for energy-efficient consumer products. Devices carrying the Energy Star service mark generally use 30% less energy than required by federal standards. Energy Star LED qualifications reduces energy costs. Uses at least 75% less energy than incandescent lighting, saving on operating expenses. Reduces maintenance costs. Lasts 35 to 50 times longer than incandescent lighting and about 2 to 5 times longer than fluorescent lighting. No bulb replacements, no ladders, no ongoing disposal program. Reduces cooling costs. LEDs produce very little heat. Is guaranteed. Comes with a minimum 3-year warranty. Far beyond the industry standard. Offers convenient Fiat Hurriza. Available with dimming on some indoor models and automatic daylight shut-off and motion sensors on some outdoor models. Is durably a €1 unregistered trademark T-break like a bulb. To qualify for Energy Star certification, LED lighting products must pass a variety of tests to prove that the products will display the following characteristics: brightness is equal to or greater than existing lighting technologies and light is well distributed over the area lighted by the fixture. Light output remains constant over time, only decreasing towards the end of the rated lifetime. Excellent color quality. The shade of white light appears clear and consistent over time. Efficiency is as good as or better than fluorescent lighting. Light comes on instantly when turned on. No flicker when dimmed. No off-state power draw. The fixture does not use power when it is turned off, with the exception of external controls, whose power should not exceed 0.5 watts in the off state. Limitations: color rendition is not identical to incandescent lamps. A measurement unit called CRI is used to express how the light source's ability to render the 8-color sample chips compared to a reference on a scale from 0 to 100. LEDs with CRI below 75 are not recommended for use in indoor lighting. LED efficiency and lifespan drop at higher temperatures, which limits the power that can be used in lamps that physically replace existing filament and compact fluorescent types. Thermal management of high-power LEDs is a significant factor in design of solid-state lighting equipment. LED lamps are sensitive to excessive heat, like most solid-state electronic components. LED lamps should be checked for compatibility for use in totally enclosed fixtures before installation, since heat buildup could cause lamp failure and/or fire. LED lamps may flicker. The extent of flicker is based on the quality of the DC power supply built into the lamp structure, usually located in the lamp base. Depending on the design of the lamp, the LED lamp may be sensitive to electrical surges. This is generally not an issue with incandescents, but can be an issue with LED and compact fluorescent bulbs. Power circuits that supply LED lamps should be protected from electrical surges through the use of surge protection devices. The long life of LEDs, expected to be about 50 times that of the most common incandescent bulbs and significantly longer than fluorescent types, is advantageous for users but will affect manufacturers as it reduces the market for replacements in the distant future. Efficiency droop: the term efficiency droop refers to the decrease in luminous efficacy of LEDs as the electrical current increases above tens of milliamps. Instead of increasing current levels, luminance is usually increased by combining multiple LEDs in one bulb. Solving the problem of efficiency droop would mean that household LED light bulbs would need fewer LEDs, which would significantly reduce costs. In addition to being less efficient, operating LEDs at higher electrical currents create higher heat levels which compromise the lifetime of the LED. Because of this increased heating at higher currents, high-brightness LEDs have an industry standard of operating at only 350 mA. 350 mA is a good compromise between light output, efficiency, and longevity. Early suspicions were that the LED droop was caused by elevated temperatures. Scientists proved the opposite to be true, that, although the life of the LED would be shortened, elevated temperatures actually improved the efficiency of the LED. The mechanism causing efficiency droop was identified in 2007 as auger recombination, which was taken with mixed reaction. In 2013, a study conclusively identified auger recombination as the cause of efficiency droop. Possible hazard to vision: tests performed at the Complutense University of Madrid indicate that prolonged exposure to the shorter blue-band spectrum LED lights may permanently damage the pigment epithelial cells of the retina. The test conditions were the equivalent of staring at a 100-watt blue incandescent source from 20 cm for 12 hours. Researchers say additional testing is required to ascertain what intensities, wavelengths, and exposure times of LED lighting devices are lethal and non-lethal for retinal tissue. See also: LED display, list of emerging technologies, list of light sources, lux, photometry, radiation angle, solar lamp, spectrometer, references. Further reading: Light-emitting diodes, 2nd edition by E. F. Schubert, ISBN 0-521-86538-7. External links: E-Lumen a website from the European Commission about the second generation of energy-saving light bulbs, LED lighting, United States Department of Energy. Efficient LED lighting in conjunction with low-voltage domestic solar PV and mains, earth.org.uk.